An object-oriented program may be considered a collection of interacting objects. Each object is capable of sending and receiving messages, and processing data. Let's consider objects of a driver, a car, and a traffic light. When the traffic light changes, it sends a virtual message to the driver. The driver receives the message, and then chooses to accelerate or decelerate, sending a virtual message to the car. When the car speed changes, it sends a virtual message back to the driver via the speedometer. The fundamental concepts of object-oriented programming include class, object, method, message passing, inheritance, abstraction, encapsulation, and polymorphism. A class defines the characteristics of an object. Characteristics include attributes, also known as fields or properties, and behaviors, also known as methods or operations. For example, a car class could have properties such as year, make, model, color, number of doors, and engine. Behaviors of the car class could include on, off, change gears, accelerate, decelerate, turn, and brake. An object is an instance of a class. For example, the object My Porsche is an instance of the car class. My Porsche has the following properties: year of 2007, make of Porsche, model of Carrera GT, color of silver. Has 2 doors, and a 5.7-liter V10 engine. A method is a behavior of an object. Within the program, a method usually affects only one particular object. In our example, all cars can accelerate, but the program only needs to make My Porsche accelerate. Message passing, or method calling, is the process where an object sends data to another object, or asks the other object to invoke a method. For example, when the object called Joe, an instance of the driver class, presses the gas pedal, he literally passes an accelerate message to object My Porsche, which, in turn, invokes My Porsche's accelerate method. Inheritance, also known as subclasses, are specialized versions of a class, which inherit attributes and behaviors from the parent class. For example, the class car might have subclasses called Porsche car, Chevy car, and Ford car. Because subclasses inherit properties and methods of the parent class, the software engineer only has to write the code for them once. A subclass can alter its inherited attributes or methods. In our example, the Porsche car class would specify that the default make is Porsche. A subclass can also include its own attributes and behaviors. We could also create a subclass of Porsche car called Porsche Carrera GT. The Porsche Carrera GT class would further specify a default model as Carrera GT, number of doors as 2, and could introduce a new method called deploy rear wing spoiler. Now, the object of My Porsche may be instantiated from the class Porsche Carrera GT instead of the class car. Abstraction is the practice of reducing and factoring out details, so that one can focus on a few concepts at a time. For example, My Porsche the car may be treated as a car most of the time, a Porsche Carrera GT, when necessary to access Porsche Carrera GT specific attributes and methods, and as a vehicle, the parent class of car, when considering all traffic in your neighborhood. Encapsulation conceals the functional details of a class from objects that send messages to it. For example, the Porsche Carrera GT class has an accelerate method. The code for the accelerate method defines exactly how acceleration occurs. Fuel is pumped from gas tank and mixed with air in the cylinders, pistons move causing compression resulting in combustion, etc. Object Joe, an instance of the driver class, does not need to know these technical details on how my Porsche accelerates when sending it an accelerate message. Encapsulation also protects the integrity of an object by preventing users from changing internal data of an object into something invalid. Encapsulation also reduces system complexity and thus increases robustness, by limiting interdependencies between software components. Polymorphism is the ability of one type, Porsche Carrera GT, to appear as, and be used like another type, Ford Mustang. Both of these types have a method called break that was inherited from a similar parent class. Yet the results of executing method break for the two types produces different results. That is, my Porsche may brake at a rate of 33 feet per second, whereas my Mustang may brake at a rate of 29 feet per second. This concludes the tutorial on object-oriented programming concepts.